Hello everyone, welcome to the lecture on complex variable. Today we are going to discuss Cauchy's integral theorem. The statement says that if f of z is analytic inside and on a simple closed curve C, and if A is any point within C, then f of A is equal to 1 upon 2 pi I integral along C f of z by z minus A into dz. Proof. Since A is a point within the curve C, we shall enclose it by a circle C1 with z equals to A as center and R as radius, such that C1 lies entirely within the curve C. The function f of z by z minus A is analytic inside and also on the boundary of the annular region between the curve and circle C1. Diagrammatically, it is represented. We can observe that the curve C is outside and C1 is a small circle encircled with a point with a radius of R. The region between the curve and the small circle is called as the annular region. Consequence of the Cauchy's theorem is integral along f of z by z minus a into dz is equal to integral along integral along c1 f of z by z minus a into dz. Call this as equation number 1 by using the consequence of the Cauchy's theorem. The equation of 1 can be written in the form mod z minus a equals to r. That is, z minus a is r e power I theta, or z is a plus r e power I theta, where theta is between 0 to 2 pi, and differentiating dz is I r e power I theta into d theta. Therefore, equation 1 implies integral along C of f of z by z minus a dz is equal to integral from theta equals to 0 to 2 pi. On substituting the z value, you get f of a plus r e power I theta into I r e power I theta d theta divided by r e power I theta, because z minus a is r e power I theta. On cancelling r e power I theta, both numerator and denominator, we get I integral theta equals to 0 to 2 pi f of a plus r e power I theta into d theta. Since r is very small, that is, when it is tending to 0, we get integral along C f of z by z minus a of dz is equal to integral from theta equals to 0 to 2 pi f of a into d theta is equal to I f of a. On integrating d theta we get theta. Substitute the limits. Theta is equal to 0 to 2 pi. So we get f of a into 2 pi I, that is on simplification by taking this 2 pi I to the other side, we get f of a is equal to 1 upon 2 pi I integral along C f of z by z minus a dz. Now let's see the generalized Cauchy's integral formula. The statement is, if f of z is analytic inside and on a simple closed curve C, and if A is a point within C, then f power n of A is given by n factorial by 2 pi I into integral along C f of z z minus a power n plus 1 dz. Proof. Cauchy's integral formula, that is f of a is equal to 1 upon 2 pi I integral along C of f of z by z minus a into dz. Now we apply the Leibniz rule for differentiation under the integral sign. We have f dash of z equal to 1 upon 2 pi I integral along C f of z dou by dou a of 1 upon z minus a into dz. That gives f dash of z is 1 upon 2 pi I integral C f of z of minus 1 z minus a whole power minus 2 into minus 1 into dz. That is 1 factorial by 2 pi I integral along C f of z dz divided by z minus a whole square. Applying the Leibniz rule once again, we get f double dash a equal to 1 factorial by 2 pi I integral along C f of z dou by dou a of z minus a whole power minus 2 into dz. After differentiation, 1 factorial by 2 pi I integral along C of f of z into minus 2 z minus a whole power minus 3 into minus 1 dz. That gives 2 factorial divided by 2 pi I, and we have minus 1 and minus 1, that will be plus 1, or minus 1 the whole power 2 we get it. And integral along C f of z by z minus a the whole cube dz. After differentiating n times, we obtain f power n a is equal to n factorial by 2 pi I integral along C f of z by z minus a power n plus 1 dz. Here f power n of a denotes the nth derivative of f of z at z equals to a. Thank you.